Wow, there you go. That's a first. So we
I've
are
never,
recording. Yeah.
yeah.
Um, so welcome everybody. Hope everyone's well and looking forward to some warmer weather and everyone getting vaccinated at least twice by the end of the summer. I'll make a few announcements after the talk because I know we want to get right to our feature tonight. I'm very pleased and honored to introduce our speaker tonight. Kimberly Tait is Curator of Mineralogy and at the ROM. And it's very interesting when you read her bio. She's one of those scientists that knew what she wanted to do when she was in a very young age. And what's interesting is, maybe she'll talk a little bit about this during the talk, the fact that there was a geologist who lived just down the street from her. So when she was young, he essentially, well, must have inspired her and took her rock collecting and whatever. And that was the start of an amazing career, which has her now working at the ROM, overseeing their collection of meteorites, and now working on the Mars Sample Return Program. So it's all very exciting, and we're really pleased that she could join us. I was hoping that she would be able to join us in person, and in fact, she was the first speaker that we had to cancel when so we had her all set up a year and a bit ago, and then you know what happened. So we said, okay, let's wait. This pandemic can't last a year, and then it lasted a year. So anyway, she's here tonight, and maybe in the future sometime we'll get an update from her, and we can all see her face to face. So the title of the talk is Raw Martian Meteorites and Mars Sample Return. And if anyone has visited the ROM and seen their amazing collection, it's got to be one of the best collections anywhere. And, you know, we're learning so much about Mars, not only from the meteorites that have landed here on Earth, but also the fact that you know, we've got the active rovers there, and now we're planning to actually bring some defined collected samples back to Earth. So that's what we're going to be hearing from Kim. And Kim, thank you very much again, and the floor is yours.
Thank you. I think you actually might have stolen my first 5 slides, so we're totally in sync on our thoughts, which is kind of interesting. But yeah, I just want to say that I really enjoy doing these presentations, not to sit up here and talk. It's really to do those conversations before the talk and after the talk, and you know, maybe over dinner or something like that. So I was really looking forward to doing this in person, but you know, things have just stretched on and on. So figure let's do this now. And then yeah, I do hope I have an opportunity to come and speak to you in person, because that is just way much more fun for me. So as was just mentioned, I am a geologist. I'm a mineralogist by training. I wanted to do this from as long as I can remember. I would just pick up rocks. I remember picking up rocks from my aunt's driveway and coming in and asking my parents, why are they a certain color or shape, or why is this one shiny when this one isn't? All those types of questions. And my parents had no idea, because they were not geologists. And you know, I'd be driving along and I'd ask them to pull over, and you know, that was just kind of how this all got started. And I'm just lucky to be able to keep doing this, and now I get paid for it, which is amazing. I've had this opportunity to be at the ROM now for 15 years. So as Randy mentioned, I did have there was a geologist down the street from me, and he was the first one to take me out, and you know, really get me excited about the world and about how things form. On a normal day, this is my place of employment. I've been there since 2007, so I've survived through the crystal opening, and we opened up our gallery in 2008. And I welcome all of you, if you haven't been there already, to please come and visit the collections, because they are really great, and they're so excited to see you one day again. And I'm excited to see them as well, because I have been home for 15 months now, and I have 5 children. And as much as I love them, I do look forward to the day when they go back to school and I get to go back to work, because it has been certainly a long period of time to be home with 5 children in our house. So I apologize if I look tired, because I am, but we have some really fun things to talk about anyway. So at the museum, we've been really focusing on building a Martian meteorite collection. We have 24 distinct Martian meteorites in our collections now, and 8 of them are main masses, which are the biggest piece of the meteorite known in the world. We are approaching, if not overcoming, a couple of other institutions around the world that have the largest. So this has been a really big focus area for us. One of the ways that we grow the collection is through donations, and we have been exceedingly lucky to have a gentleman that lives in St. Thomas, Ontario, that has a passion for meteorites. He came to the ROM as a small child, and one of the docents said, if you can pick up this meteorite, you can have it. Of course, it was 3-4 times the weight of him, and there was no possibility of that. But that first interaction of space and touching, that tactile experience at the museum, really had an imprint on his lifetime. He's a medical doctor by training, and as he's getting closer to retirement, he's really gotten interested in meteorites and collecting meteorites. And we work with him and get these meteorites to the museum through tax donations, and it's just a lovely partnership that we've grown. As well, we do have a means of purchasing meteorites, which has been an exceptionally fun part of my job, to be able to go out and acquire some of these materials, especially the big one in the middle there. It was from a bequest of a donation to the museum, and Louise Hollystone left $50 million to the museum, and the interest that comes off that each year, we're able to put in applications for sort of these large, really impactful pieces to the collections, and we've been working very hard to build the collection in that way. So it's a fun part of my job, and I really want to stress that I did not come into the museum as a meteorite person, so this has all been on the job learning, and it's been such an exceptional part of my job is to welcome these meteorites in and study them. And with my connections to the University of Toronto, I'm able to have students in my laboratory to come in and work on them, and it's just been a great way of doing my research. So I should probably back up and explain what a meteorite is. A meteorite is a piece of, especially a Martian meteorite, is a piece of Mars that has been impacted off the surface of Mars, has been launched up into space. And if we're lucky enough, the Earth, it gets close enough to Earth that our Earth's gravitational pull will bring it in, and it will land on Earth. Earth is almost 3/4 water, so we do lose a lot of material that way. But if we're lucky enough, some of it will land on the surface, the terrestrial parts, and can be recovered by people. Some of them are witnessed, so sometimes people can see them falling, which is great, and sometimes they're not, and they're just discovered and brought in for eventual, hopefully, making it to the museum. Now, depending. This number fluctuates a little bit, but we're approximately about 165 unpaired. So meaning that you know, sometimes when rocks fall, they will split up in the entry process or even prior to the entry process. And what happens is that, you know, piece A and piece B can be paired or put back together due to chemistry or a lot of different reasons. They can be put back together as being from the same source. So we're in the range of 165 Martian meteorites, plus or minus a little bit. But, you know, so we're really excited to have the 24 samples at the ROM. You know, why are Martian meteorites so important? You know, there really are only physical samples from Mars at this point, but we're hoping to change that sort of in the next little while, and I'll be talking quite a lot about that. You know, there's been a lot of, you know, remote sensing and rovers that are happening, which I will also be talking about, but, you know, we really can't do those, you know, those in-depth analyses that we do with normal Earth rocks, and that's how I sort of got into this business, was through Earth and studying minerals on Earth, and then sort of transitioning that to the Martian samples. And, you know, sometimes people call them the poor man's space probe. I mean, we're not spending billions of dollars to get these samples brought back. These are just things that are happening naturally and on their own, and we can take full advantage of that. And we have this little haha, and you would be laughing if I could hear you, but I can't. So anyways, the main question I get is, well, how do you know they're from Mars? And you know, there was a lander that the Viking Lander that was at Mars in 1976, and it was collected some information about the atmosphere of Mars. And then around that time, people were noticing on the rocks, the Martian samples, that there was these black areas here that were different than the other material surrounding it. So looking at those areas closer, it was determined those are glass. So these are minerals that formed on Mars originally, but in that impact process, when the rock, you know, launched, hit Mars and hit it hard enough that it actually was able to extract the material and overcome the forces that keep the samples on Mars. That impact process can then heat and melt some of the minerals. And in that process, what happens is that it can actually trap some of the gases from the atmosphere. And lo and behold, you know, they looked at the composition of the atmosphere on Mars, and they looked at the composition of the glass and the gases trapped within the gas, and they were a dead match. So until we have samples directly from Mars, this is as close as we can get to sort of pairing them with that planet, but feeling pretty confident that the science does support that these are from Mars. So really my research, I'm not going to get into it too much tonight because there's so many really cool things to talk about. This happened in the last even couple of months, so I want to get to that quicker. But you know, really my research revolves around understanding how Mars works. You know, we have, this is our closest planet to our own, and I'm really interested in understanding how these two planets that were, you know, probably started off very similar, took totally different paths. And, you know, why do they take different paths? And, you know, why does one have an atmosphere that's almost totally carbon dioxide? And why does one have water, one doesn't? One has life, one may or may not. There's a lot of questions that are still outstanding, and that's where I focused a lot of my research. And from that research and from the collections, I would argue that has opened up a lot of opportunities for me within the community. So there's been so many missions to Mars. I will not be able to talk about all of them, including, you know, some of the news in the last couple of months. You know, we have a new orbiter from the UAE. We have a new rover that's been on the surface only for 2 weeks now. So there's a lot of exciting things that are happening on Mars research. But I'm going to really focus in on Perseverance and the Mars 2020 mission tonight to talk about you know, how that fits in with me and the ROM. So we're going to focus in on that. So February 18th, 2021, so just very recently, we have had a new rover to the surface, which is called Perseverance. Now, I'm going to try playing a video and we're going to see how this works. I'm hopeful. Okay, 1 sec. Probably because I have headphones and this isn't going to like it. So I'm going to, how are we going to do this? I didn't say this is going to be easy. Didn't like that. So let's do it this way. We're going to do it on the smaller screen. Can everybody hear that? Give me a thumbs up.
Okay.
Okay.
Entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. Parachute has deployed and we're seeing significant deceleration. The heat shield has been separated. Perseverance now has radar lock on the ground. The backshell has separated. Skycam maneuver has started. About 20 meters off the surface.
Tango Delta, nominal.
Touchdown confirmed. Perseverance, please.
Kim, is there a way you can go into just, we're seeing your current slide, your next slide. Is there a mode you can go into just to show the one?
I'm sorry, so what do you see?
We're seeing your main slide and then your next slide beside it.
Oh, you're seeing the presenter mode. Okay. Yep. Got you.
Thanks.
See, this is why I like doing things in person better. I was saying that, right?
It's fine. It's just since you're, oh, there we go. Perfect. Thank you.
Will that work? Okay.
Yep. Excellent.
All right. So also on that day, I don't know if anybody was able to take advantage of this, but it was also the Mars Donut Day at Krispy Kreme. So I drove to Mississauga and took advantage of that. So there was, obviously from that video, there was successful landing on that day. And although there have been rovers on the surface of Mars before, and there has been some since, this is a very unique mission this time because there is a drill on the end of that arm that is going to be collecting material to bring back to Earth, hopefully in 2031 or 2033, depending who you ask. So it landed in Jezero Crater, And this is a deltaic system. So you can see that there's the sort of the highlands there in the background, and what is thought to have been flowing water that was bringing sediments down into the basin. And this is very similar to deltaic sediment systems that we see like in south of New Orleans, for example. And really one of the biggest parts of this mission is to assess for ancient habitability. You know, if you're going to look for life, one of the places you can look for is where there was potentially water. And that's what geologists interpret this area to have had. You know, we're seeking signs of ancient life. We're probably not going to be seeing ancient life like this, but we're hoping to see carbon-based materials throughout the rocks, or even signs in the rock record to have shown that have interacted with life. Wherever there's life, it tends to alter the rocks in some way. So this is an extremely diverse landing site, and you can see the green squiggly line that goes up the hill there, and that's going to be the sort of the traverse path for the rover. And as it goes along, it's going to have to make some decisions on where to collect some of the samples.
We are working on something that is the cleanest we've ever really attempted to set in space.
The Perseverance mission has as its central goal astrobiology and also being the first step in Mars sample return. We're going to collect a suite of samples, about 35 samples, that each weigh about 15 grams.
And the reason we collect those intact samples is that we are the first mission that's part of Mars sample return, and it's our job to collect the samples intact to be brought back to Earth for further analysis.
To better assess the question of, was there life previously on Mars? Inside the belly of the rover sit a number of sample tubes in an entire adaptive caching assembly that is used to help collect these samples. Extraordinarily complex robotic system. And to make it even more complicated, it has to be super clean. We don't want to have these samples come back from Mars and discover life in them, but then realize, oh, that's life that was in the apparatus when we sent it to Mars.
That was a big challenge for the mission because we were meeting cleanliness standards that no rover mission has ever had to meet before.
The requirements that we have for this mission are extraordinarily challenging.
Once we would go through machining the tube itself, getting all of our protective coatings on there, and then looking at our beautiful tube, we found carbon contamination which we were not expecting. So as a team, we all had to really come together and look at the entire manufacturing process, how we're handling these tubes, and start polishing the interior more prior to putting on some of our protective coatings.
It meant having to come up with an entirely new technique to clean all of the hardware and demonstrate that the hardware could maintain that cleanliness all the way to Mars.
That's what JPL does. I mean, we discover problems and then we solve them.
Having these very strict controls and this record of how much contamination or how clean these tubes are prior to going to Mars is essential for that return sample science.
Great discoveries require remarkable evidence. And so the cleanliness of the sample tubes and of all the hardware that's going to be collecting those samples is paramount in making sure that the evidence and that the story and that the discoveries that come from these samples that are brought back are irrefutably Martian.
We are
Now, as part of the rover, this was one of the bonus parts of the mission. There is a helicopter or a drone that was on the underbelly of the rover. And really, honestly, this doesn't have too much to do with my talk, but I am just one of the biggest Ingenuity's fan. I think this is just exceptionally really cool. So it's just this 4-pound little helicopter that was only supposed to fly a couple of times, and they wanted it to sort of die after 30 days because the rover needs to move on and start working on its main objectives. But it has been going so well that it just keeps kind of going. So it has an extension on its life. So I won't show this because I probably don't have too much time to do it, but I really recommend that you try to find this on the internet and listen to the sounds of this helicopter flying on Mars for the first time. It is exceptionally cool. And we'll just play it for like 2 seconds. Oh, better just keep going. So this is what Randy mentioned just really briefly on our conversation prior to my talk, was that on its 6th flight, which was yesterday, that was one of the more advanced flights. So every time that it takes off, it's just going a little bit further. So this was supposed to be a 150 meter flight. That was, only, I think it was 10 meters off the ground, and things were going okay until right at the end, and it became adjusting its velocity and tilting back and forth in this pattern that this persisted throughout. And there's some wild images and videos of this thing sort of tumbling through, but it did land safely and has a lot of people having heart attacks, but certainly it survived, and non-nominal things happening along the way is expected, and they're going to learn so much from these moments. So it's a very exciting project. So there it is, tumbling away. So back to Perseverance, because I could not show that. It's been in the news the last little while, and it's so fun. But anyways, so the sample return mission is going to be done in 3 phases. So there's going to be sample selection and collection, and that's Mars Perseverance, the rover, going to be on the surface for quite some time, and it's going to be drilling those samples, putting them in sample tubes, and leaving them behind. Eventually, there's going to be a sample retrieval system that's going to be launched, and it's going to transfer them to a apparatus that's going to be launched off the surface of Mars and then be returned to Earth. So it is quite a complicated system that needs to happen. This is maybe a slightly better, it gets more and more complicated. So I just wanted to show that first one to get the sense of the steps. But really, Perseverance is just the first in a long set of missions that need to happen. And it's not only by NASA, this is going to be a NASA-ESA, the European Space Agency partnership, which is a really interesting part of this project, and something that I've been dealing with personally is understanding those relationships between the two. So Perseverance is operational. It is on the surface right now, which is great. In 2026, there's going to be another launch of another spacecraft, which is going to be the little Fetch rover, which is going to be collecting all the tubes along the surface. And then another spacecraft is going to be launched at the same time, and that is going to be just orbiting Mars. Once all the sample tubes have been picked up, it's going to be launched off the surface. It's going to be captured by that Fetch mechanism that is orbiting. Then it's going to be flying back to Earth. We're going to stay positive. We're going to say 2031. So that's the series of events. I only show this just because it's even more complicated than that. But really, one of the most interesting parts of this, I think, is that if you look kind of in the Mars Ascent Vehicle and the orbiting sample, basically there's going to be this sort of basketball size where all the samples are being held. And when it's launched off the surface of Mars, that outer part can't come to Earth because we don't want to have Mars material landing directly onto Earth. So it's this thing called break the chain. They're going to have to recover the Oz and then bring it back completely contained in something that has never been to Mars before. It gets very complicated very, very rapidly, but it's a really exciting series of steps that need to happen. So lots to do. So this is another picture of the sample rover. And again, I really can't stress enough how important it's going to be to keep the materials from Mars separate from Earth. That is to protect our planet, to protect the samples, and has made things extremely complicated for this mission, which is why I'm already working on it now. So I just found this today, and I need to look more into this, but I noticed that a local company was given a $400,000 contract to work on the samples. That's Rover mission. I hadn't heard of this before, so if anybody knows more about this, I certainly want to talk about this after the talk. So just a little shout out to Canada here. So this is one of the concepts of the Oz. So it's just the orbiting sample container. And again, we have these sample tubes. The rocks inside are about the size of a piece of chalk. And there's going to be 43 sample tubes that can fit into that basketball, basically. So there's only going to be enough for approximately 30 samples to come back. So there's going to be a lot of discussion of how to best get the materials back. You know, they're going to be drilling. It's kind of, you know, when you're driving along and you see something really interesting and you want to pull off, but you only have X amount of hours, so you have to kind of make decisions and you can't go back, right? So there's going to have to be these constant check-ins of, you know, do we need this rock? Is this going to be the best rock we're ever going to see? What if there's a better rock over the hill? It's going to be very, very tricky for the Mars rover team to come up with the answers on how to do that. Thank goodness I am not part of that. Chris Hurd from the University of Alberta is one of the main rover team members, and so another Canadian that's working on this mission. So this is the launch. So that's going to again happen about 2028. And this is the Oz. You can see that little basketball that's floating up into space, which is just wild. I mean, we've never launched another rocket off another planet, so that's going to be a huge engineering feat as it is. But then this concept of just tossing a ball up into the air of space and capturing it and bringing it back to Earth is a whole other thing. But then once it gets back to Earth, we're going to have you know, a whole series of things that need to happen to these samples, and that's where I sort of kick in. So these materials are going to be treated in the highest biosafety laboratories that we have here on Earth, which is called a BSL-4 facility. As it's planned right now, these will probably land in the United States, probably Utah, but they haven't fully released that yet. And they're going to be treated as something that we're dealing with all right now, like coronavirus or Ebola. They're going to be treated in the most highest facilities that we can deal with. And we've never dealt with rocks before in such a facility. So there's a lot of planning and thinking that needs to happen as far as how best to handle these materials, and also to get the most science out of it, because we want to get these samples into the facility and then out of the facility to be able to study them into each other's laboratories. I was asked to serve on the Mars Sample Return Program group, the first one, and I had the opportunity to travel to the United States and then also to the United Kingdom to work with a bunch of people from around the world on some of the planning of the science and the contamination control and the curation steps that will need to happen to bring these samples back. So you can see me there all in my suit. We went into one of, it's called a double wall isolator. One of these facilities is being built in Leicester, United Kingdom, and we were able to have a look at some of the early concepts of this type of facility and box that will have the samples in the future. I must not have done such a bad job, because I was asked, I applied and was selected for the MSPG2, so that's the Mars Sample Program Group 2 team, and we were struck right around the time of COVID starting. And again, these are researchers from all around the world, approximately half from a European Space Agency people that were selected. And I note that Canada is a part of ESA. We're a member state of ESA. I didn't even know that until the last couple of years. So that was news to me. And then all of the NASA people as well. And we're all working together. And we've been split off into sort of 4 main groups, I'll say. One of them is curation. And so Caroline Smith from, she's right here, she's from the Natural History Museum in London, sort of the ESA head, and then Frances McCubbin works at NASA Johnson Space Center, and the two of them were co-leads of this group. And then I was brought on as the third, so the three of us were the co-leads of the curation focus group. And we have been meeting every week, to talk about curation needs of the samples. And it's been quite a long ride. And just recently, May 13th, I submitted a 66-page report, and that box moved a little bit, but I am the first author of the report. And I have worked on this literally endlessly over the last year, working on all of the details of how we're going to handle this material, from coming up with 3 different characterization stages to coming up with a list of analytical equipment that we're going to need to do these measurements, as well as all of the curation handling, thinking of how many facilities we're going to have, because there's also political pushes from, not having all of the material in the United States, because some of the money and input is coming from the Europeans. So how we're going to separate these materials across the world. And then Europe has a whole other series of issues. One of the points was supposed to go to the United Kingdom, but now they're not part of the European Union. So there's a lot of things that need to be worked out, and we try to do our best to come up with what's best for the samples at this point and try to ignore politics, but that is going to come into play for sure. I just put this picture in because it's one of the more recent images of the surface of Mars, and I just look around at all of these samples that are just sitting there waiting to be analyzed. And I'm just so excited for this material to come back and come into our laboratories so we can make some more observations, not only from the samples that we have in collections already around the world and also at the ROM, but some of the new samples that we'll be recovering, such as sedimentary rocks and regolith and materials that would never survive the transit through space, but that will be recovered from this mission and be brought to a sample receiving facility, hopefully in the next decade. So I just really want to stress that we've been aggressively building the ROM's Martian meteorite collection. It's been something that we've been doing since even before I arrived, but that's been something since I arrived we've really been focusing on doing, and this is done both through donations and acquisitions from the collections, and it always comes back to the collections. As a museum person, we're able to do really exciting research, and not only that, but high impact research that has been noted by, obviously by NASA and ESA, because they've asked me to have some input on the missions that are ongoing. From that, we're getting globally the ROM in Toronto and Canada, which is really exciting. We're getting recognized globally as leaders in both research and curation. And I'm just excited to work on this project. And it sounds like we're going to be, literally yesterday, there was a presentation of our work that has gone to NASA management and ESA management. And we're coming up with, we had a series of recommendations of things that need to be worked on in the next couple of years. And Mars Sample Return Program 2 should be winding up probably in June, but I've already been asked to stay on over the summer to work on more of the analytical side of things, to have my input for the instrumentation that is required to study these samples. So I'm really looking forward to working with the Jet Propulsion Laboratory directly and the engineers on how to be able to fit into all these instrumentation into the sample receiving facility. So it's super exciting. And I always put in this picture because it was such a fun way of using the collection that is a well-known astronaut and sort of a well-known actor, I would suppose. And that's our sample from the ROM that went in Mrs. Hadfield's purse to TIFF when the Martian premiered here in Toronto in 2015. I did try to interject myself into that, but I was not allowed to come, unfortunately. But it was in safe hands with Mrs. Hadfield. So anyways, that's just a fun way of the collection being used in different ways. So with that, I'm going to open it up the floor to questions.
All right, Dr. Tait, thank you very much. So let's, we have the chat there. So if you have any questions for Kim, please, please start typing away. I wanted to ask, you know, something I've been wondering, especially from the Mars rover missions, I guess, you know, 20 years ago, how they were able to determine that where the rovers were, there had been water, say, a billion years ago. And they talked about certain types of rock that they were looking for, but also salts. Could you talk a little bit about how they can just sort of sample with the technology that they had and then, you know, determine that what it was like a billion years ago on that site?
Yeah, so you're making me look backwards, and Brandy, you probably know more about this than I do. But you know, so my knowledge of the rovers is more curiosity on. So I can't speak to decades ago of how they were able to do that. But some of the measurements and thoughts that they had, you know, decades ago still stands true today. I mean, there's always been the understanding that there was water on that surface of that planet, and you know, the more and more we see from imagery, from all of the tests, from Curiosity, from Perseverance as well, I'm sure, and very soon is all supporting water on the surface of the planet. And you know, there's just a diverse set of rocks that are there. You know, unfortunately, just the basalts and the volcanic rocks make it to Earth, but you know, we do see sedimentary rocks. We do see salts and perchlorates and things that would have interacted with water. And you know, I would be very shocked if we don't see more advanced carbon-based materials that come back with Perseverance, because there's everything, you know, all the ingredients are there for some form of life. And you know, really, when you get down to it, it depends what you define life is, I guess. But I think we will find, you know, extant, you know, not living materials, hopefully, because that's going to make this mission even more complicated. But there is, I think, a lot of hope that there's going to be extant life present in the samples, which is very exciting. And I think, you know, we're still learning so much even about the Apollo samples 50 years later. I think these samples coming back are just going to give us, you know, lifetimes of experiences with, you know, and studies as, you know, analytical equipment becomes more and more advanced. What we're going to find, it's very exciting.
Okay, thanks. Thank you, Kim. I didn't mean to put you on the spot there, but
no,
yeah.
that's okay. Yeah, that's why I'm here. I think that's the whole point, right? So.
Yeah, you're definitely a better geologist than I am. Okay, so one of the questions here was, will the sample return craft require some sort of protection from solar radiation?
Yeah, that's a very good question. I think the idea from the return craft was that it's going to be solar. There's going to be panels for solar power, but you know, I don't think it would need. I mean, none of the rovers have needed protection from solar radiation that I know of.
Plus, the solar radiation on the surface of Mars is pretty extensive anyway, right?
Yeah, exactly. So yeah, so not to my knowledge.
Probably not. Just what the spacecraft would need to get back to Earth. Okay, another question here. Did the moon rocks have to go through the same biosafety procedures, or is it different because it's Mars, which may have been more likely to have had life?
That's an excellent question, and no, it didn't. And you know, maybe now if Apollo happened, that would have been a different story. But in the 60s, there was no planetary protection office at NASA, and those samples were brought in and worked on with, hands-on right away. So, and they were transported in, in briefcases on planes. So there was no biohazard. Certainly, I think Mars has a lot more probability of life comparatively to the moon. So yeah, that's. Sorry, Ian? Oh, okay. I didn't know if you had something else to say. But yeah, but no, that wasn't the case for the Apollo samples.
All right. Yeah, it's all I remember is when the astronauts came out of the spacecraft, they washed them down, and then they threw all the sponges. They attached them to weights and then threw them in the ocean. So definitely
not the same. No,
not quite. No. All right. Ali has asked, assuming that there is microbial life in any of the samples, is there any guarantee that they get preserved or survive in the tubes for a few years?
That's also a very good question, and something we argue about almost weekly, because the probability of something sitting in a titanium tube on the surface of Mars for years, it's already been sitting on the surface of Mars for X amount of millions of years already too. Probably not, but that's why I kept saying extant life, because at one point, hopefully there was the opportunity for some sort of life, and we, even extant life will be very interesting to find. So I hope, for a lot of reasons, I hope that it's present but not alive, because I want to be able to study these in my own lab.
Okay, Swapna has an interesting question. Will the ROM be engaged in the Bennu OSIRIS-REx sample return collection analysis?
Absolutely. So that is very exciting. We have a Canadian instrument on board, OLA, which turned out to be a very important instrument for the landing site, more important than we thought it was going to be originally, because OLA turned out to be, Bennu turned out to be really, really rocky, a lot more rocky and irregular than we even thought before we got there. And I am on the science team. I'm a participating scientist on the OSIRIS-REx mission, and I am in the process of becoming a co-I, so on OLA. So they're working on the paperwork right now, and I'm being elevated for that. So, and as part of OSIRIS-REx, Canada will be receiving 4% of the material, and we're really working hard to come up with the answer of where that material is going to go. But if I have any say in it, it will be downtown Toronto, but I'm still working on it, so we'll have to see.
Okay. Let's make sure I get the next question here. Yeah, from Dale. What do you propose has happened to the water on Mars? It looks like it was a significant flow at one point.
I wish I knew. And I think that's one of the most fascinating questions about Mars is, where did it go? What happened? So, I mean, we know that the atmosphere is, there's no protective atmosphere like we have on Earth. So that doesn't help, certainly. There's a lot of thought that some of the water escaped, by evaporation, and just, we don't have a water cycle there, and it just, went out into space, and that was it. There's some more recent papers that were saying that the water has been absorbed into the subsurface. So I don't think we know, and that's something that these samples, I think, will give us a lot more insight on some of the processes. My research really gets down to almost it is to the atomic scale, and really when we get down to those scales, we can see things that other instruments and other methods can't see. And I think some of the research that we're doing now is coming up with methodology to start asking those questions from a mineralogical perspective, at least. We'll be able to see, some of the minerals, do they have water in them? And if they don't, why is there not water there? And you know, we're going to have some really great, I think, science answers in my lifetime. I'm very excited about. But the short answer is we have no idea.
Okay, a question about the ROM collection. Is there special handling, or can they, if you visit, can you touch some of them with your bare hands?
Yeah, no, that's a really great question. So really a lot of the material that we get at the ROM is from Northwest Africa, and a lot of that material has been handed by people over and over again prior to getting to our collections. So yeah, we don't tend to use any special handling because they've been on Earth for hundreds, thousands, millions of years already, and so there's no probability of biological containment or of interaction at all. And some of the carbonaceous material we do have glove handling for, not for protection of us, more for protection of the sample. We don't want to have our biological, because some of the studies that are done from the material is on organic studies. So, but otherwise, there's no special handling. There's no, the rocks that come back from Mars, especially, are basaltic. So we wouldn't expect for life to be as prevalent as the sedimentary rocks and stuff that we brought back. So.
Okay, here's an interesting question. Why spend so much, I guess, money bringing things back when we might just spend less by sending more analysis ability to Mars?
Yeah, no, that's a great question, and one that is asked quite a lot. So what we've, so far the investment has been 2.9 billion and growing on this mission, and that's just on Perseverance. And I talked about a lot of other steps that need to happen after that. So this is a significant investment in materials, but I think arguably bringing these back to Earth, just like the Apollo mission. I mean, we have samples that we're still having, huge investigations, groundbreaking investigations on Apollo samples 50 years later, and that's just a testament to how important sample return missions are, because these are precious materials that are coming from another planet, and our analytical ability is going to keep evolving, and instrumentation is changing yearly at this point, even half a year in some scales as well. So we're just going to be able to study them better and better if they're back here on our planet. So I think it is a good investment, and I just can't wait to get this material into laboratories and see what we're going to find.
Okay, here's an interesting question. I like this one. Any noticeable differences between the Martian meteorite basalts and similar terrestrial basalts?
Yeah, no, it's a really good question. There is a lot of similarities, of the major mineralogical, makeup is very similar. When you get down to the trace elements, then they do get a little different, but otherwise they are almost identical from a sort of a first pass. A basalt is a basalt, and even a granite is a granite, which we find on Mars as well. So they are very, very similar, and so that's why I am able to sort of take my background in understanding. All my education was on studying rocks from Earth, but I am able to easily apply it to moon rocks or Mars rocks or whatever, because when it comes down to it, they are very, very similar, more similar than you would think. The only places where they get really different is some of the impact processes that have happened. So that, that really dramatic launch of material, we start to see high pressure minerals that we wouldn't find on Earth. There's some differences there, but otherwise very, very similar, which is also very interesting in some ways.
Okay, a question about analyzing the samples in life. Assuming no fossils, what markers of extant life would you expect hope to find.
Really smart
And
question, Keith. Yeah.
in a lot of the pictures of Mars, the surface seems strewn with boulders. Are those the result of meteoric? Well, I guess there are two questions here. Sorry. Let's do the first one first about the no
Yeah,
fossil.
sure. Yeah, no, that's a great question. So yes, we don't expect to find, dinosaurs or, other sorts of even, clams or, even down to shells or, so what does that start to look like, right? It's, these might be sort of bacteria that we might find, sort of like stromatolites on early Earth. We might see that, sort of black strings of carbon material that is within the rock record. But we don't know yet. We have no idea exactly what it's going to look like. And I think even if we tried to predict, I don't think we're going to get it right anyway. So I think we're going to have to wait and see when these samples come back. But I think it's going to be pretty significant when we see them. That's just, I said it first. You have to wait till 2031. And then, yeah, the second part of the question there is the surface seemed to be strewn with boulders. Are those the result of meteoritic impacts, or there's other processes at play? Mars doesn't have plate tectonics. It's sort of a dead planet from a geological perspective. There's no flowing water. There's no, processes that sort of recycle the material like we do here on Earth. So that's one part of it. But yeah, it's also hit a lot by extraneous material that's coming in. It doesn't have an atmosphere to protect itself from it, so you can see huge craters all over the surface of Mars. So I think there's sort of two problems there. You have sort of those impacts that are breaking up the surface of the material, and then you don't have any way to sort of recycle it or to get rid of it, so it just stays put. So yeah, the surface is quite rocky. Just like in that one of those last slides I had, you can see just all that strewn field of rocks everywhere. So
I noticed on the Chinese lander and rover, it actually landed fairly close, I believe, to Viking II.
Yep.
And the Viking II landing site was just strewn with boulders.
Mm-hmm.
And its site looks more like Spirit's landing site. It's pretty.
Yeah.
So. That's
I don't know.
Surprise.
I don't know, but it's what's super cool about Perseverance, and I didn't get into it too much. I didn't really show it in the video. Is that it was calculating as it was landing sort of the safest spot it could land, and this was all done. All this had to be programmed and sent prior to its actual landing, because there's too much time before the communication from Earth to Mars and back to Earth takes over 10 minutes. So all of this sort of happened on its own. So it was able to, as it was descending, was calculating, it was constantly looking at the surface, trying to find the most flat, safe spot for it to land. And I thought that was one of the more cool things about it, is that it was able to sort of protect itself or save itself. And sure enough, it landed sort of dead in the center of the most flat part of the basin, the Jezero crater there. So
yeah, nothing will beat the video or the pictures of the landing too. I mean, that's just
so neat. The sky frame, mind blowing. The parachutes and yeah. I don't tend to show that many videos, but as I was going through and preparing for this, NASA does such a great job of sort of communicating the main points. It's almost hard not to show the videos and images, because go on there and just have a good look at what they're producing, because it's so informative. And there's activities for kids. If there's teachers on this call at all, it's such a great site. So I use it a lot for communicating what they're doing.
But of course, the 2026 lander has to land rather close to Perseverance.
It does.
And they're getting good at this. I mean, the error ellipses are getting smaller and smaller.
Very small, yeah.
So that has to happen. And is there another spacecraft that has to land with the ascent vehicle then after the 2026? Like the rover?
Rover, it's rover and then launch and then catch.
Okay.
Right. So so the third one is the catcher, I guess, if you will. Okay. So.
And once they launch, they have to go into orbit and rendezvous, which is not a trivial thing too. No, there's a lot that has to,
Has to go right.
Yeah, a lot of critical parts.
Yeah.
So what are your thoughts on humans going to Mars, and maybe even well, of course, geologists will go to Mars.
Well, geologists will be the first ones to go, of course. So I don't know. It's there's big dreams and big hopes to get humans to Mars. I mean, that's sort of one of the main goals of this mission, is to sort of understand. There's MOXIE, I think that's the oxygen monitor, and they're trying to find ways of converting atmosphere into more breathable gases. There's a lot of things that are happening. There's been talk of getting humans there in the 2030s, but I don't know. It seems pretty bold, but who knows? Who knows? There's especially when we get into other financiers that might be able to play in this game too. We don't know. And other countries as well. It's not just NASA. It's not just a NASA game anymore either. So maybe it will happen. So I think the first step is to get back to the moon and do that first, and then build towards humans on Mars.
I had a question about going back to the moon. Obviously that is in work now, and hopefully a Canadian astronaut will be involved with a landing at some point. Can you comment on what the current lunar geology or geologist community are looking forward to doing once they go back to the moon, based on analyzing all of the current lunar samples?
That's a good question. I think really the push is to get people there, and we've learned so much about the lunar geology since the time of the Apollo missions. I mean, at that time we just landed at the flat parts because that was the easiest place to land, and we wound up sampling just all of the new rocks, the mare, from so we wound up sampling hundreds of kilograms of the same stuff. So I think from a geological perspective, if we get to the highlands and sort of sample some of the more older material from the moon, that's what I would think is. But I mean, there's all sorts of thoughts about mining the moon and using resources from the moon to get us further, and there's lots of talk of a lot of things we could be doing with the moon. So I guess we'll see, but I'm really excited for some of the announcements from just this week on, and that could be a whole other talk of some of the exciting lunar investments that are being made by the Canadian government and the CSA. So I think there's a lot to be watching in that area for sure.
And it's exciting that a lot of these pieces are just being built up on the other side of the airport in our neighborhood. Yeah, really
I don't think people know that, and that's why I kind of threw in that connect. It's good to know that Canada is really being involved in these missions more and more, and a lot of the bits and pieces and instrumentation and stuff is all being built in the GTA even, and if not across Canada. So and then not only that, but Canadian astronauts and Canadian scientists are being involved, and it is an exciting time, I think, in space exploration for Canada. So we're going to have our first sample return coming soon, like really soon, 2023. We're going to have material from an asteroid coming back to Canada, which is super exciting. So it's a good time to be a geologist in planetary science.
Well, thank you very much, Kim, for your presentation and answering all our questions. We really appreciate it, and a lot of comments in the chat already about how people have enjoyed your talk. And as you say, this is an ongoing story, so we'll definitely look forward to getting together with you again sometime and getting an update
in person.
In person, yeah.
All right.
And you can bring your kids.
Oh, we're not doing that. Unless somebody wants to run around with them, I don't think that's a good idea. But but thanks for the invite. I appreciate it. All right.
Okay. Thanks again.
All the best, everybody.
You take care. Have a great weekend.
Yeah. Thank you.
You're welcome to stay. I just have a few announcements before we close up.
Okay. Yeah. Yeah, I'll go. I'll be quiet.
Oh, okay, okay.
I'm here.
All right, so just a few announcements. Messenger is out, the latest issue of Messenger. There's an article on the upcoming solar eclipse. And there's also a timely article by our honorary president, Uli Krull, on some analysis he did on a lunar meteorite. So that's very timely, Uli, and I enjoyed reading that very much. It's very cool. So that's in this issue of Messenger. We've expanded our groups IO, and there's information on this in Messenger as well. So we added a beginners and an observing groups IO to the astrophotography groups IO. And depending on how active they get, we may be adding some others down the road. But we are looking for some volunteers to help us monitor these groups and even, you know, generate some discussion points in that. For our new members, we have a new members welcome evening on June 8th. There'll be an email about that on how to join it, but essentially it's a Zoom meeting like this where we introduce you to the club and answer any questions you may have as a new member. Our next meeting is June 11th. That's going to be a potpourri meeting. And remember that the early morning solar eclipse is on June 10th, sunrise eclipse. So we will hopefully have a full program of observations of this rather unique sunrise, which will be a partially eclipsed sun. So that's our potpourri night on the 11th. We've canceled the speaker night for June 25th because the virtual General Assembly will be underway. And there's information in Messenger on that. So I encourage everyone to register for the General Assembly. There are a lot of great speakers, and that will be taking place through the weekend of the 25th to the 28th. And I'll ask now if anyone has any comments, questions. If I missed anything? Okay, if not, thank you again to our speaker, Dr. Tait. Thanks everybody for coming. We had a great attendance tonight. We had just under 60 people, which is awesome. So one of these days, I'm hoping that come, if not September, October, we'll be able to get back to meeting together and observing together. That would be great. We'll just have to see how successful things are in the summer. So if that's all, I'll everyone get vaccinated and get your second vaccination when you can. And we'll see everybody in 2 weeks. Take care.
Night.
Thanks, Randy.
Hey.
Thanks, Randy.
You're welcome, Beulah. Thanks. Good to see you.
Yeah, nice to participate in this. Thanks.
Okay. Hey, Jose.